So you want to own an AI data center. There is a building in the middle of the American desert that brings more electricity than the entire city of Buffalo, New York. It has no windows, almost no employees, and it generates more revenue per square foot than any hospital or skyscraper on earth. Nobody talks about it, nobody tours it, and the people who own it. They are quietly becoming the most powerful landlords in human history. This is the economics of owning an AI data center. And by the end of this video, you are going to understand exactly why the biggest companies on the planet are mortgaging their futures to build more of them. There is one thing that separates the interesting businesses from the extraordinary ones, the gap between what it looks like from the outside and what is actually happening with the money on the inside. An AI data center looks like a warehouse, a very, very expensive warehouse. But what is happening inside that warehouse is nothing short of the most capital intensive business model human civilization has ever produced. Here is the shift you need to understand first. For most of the last 20 years, when people talked about data centers, they were talking about storage. Companies needed somewhere to keep files, emails, customer databases. Those buildings were basically digital filing cabinets. They were boring, they were profitable, but in a slow, predictable way, like owning a self storage facility. Then AI happened. And when AI happened, the entire infrastructure of the internet had to be rebuilt from scratch. Because here is the thing about artificial intelligence. And this is the insight that unlocks everything else in this video. AI does not store information. AI processes it constantly, aggressively, at a scale that makes your laptop look like a calculator from 1987 the moment the world decided it wanted AI generated answers instead of Google search links. The demand for raw computational power did not increase gradually. It did not double. It did not triple. It went vertical. And the people who had built the infrastructure to supply that power, they became extraordinarily wealthy almost overnight. So let us get into the actual numbers because this is where it gets genuinely insane. Let's talk about what it actually costs to enter this business. And I want you to hold on to something as we go through these numbers because every single figure we are about to cover is real, documented, and verified. This is not speculation. This is the math that the largest companies in the world are running right now. In the data center world, you do not measure size in square feet. You measure it in megawatts. Megawatts of power capacity. That is the language of this industry. And once you understand it, everything else clicks. A standard commercial data center, the kind that a mid-sized bank or regional hospital might use, runs at around 5 to 20 megawatts. This is what the industry calls enterprise scale. Respectable, functional, profitable. An AI-specific data center, you are starting at 50 megawatts, the new generation of facilities being announced by Microsoft, Google, and Amazon. Some are targeting 500 megawatts to a full gigawatt. This is not a typo. 1 gigawatt. The kind of power output associated with the nuclear reactor. But let us be conservative. Let us walk through what it costs to build a 50 megawatt AI facility. Because even at that entry level scale, the number will reset your understanding of what a big investment actually looks like. You cannot build this thing anywhere. This is the first trap most people fall into when they think about this industry. You need three things to coverage in one location. Access to enormous amounts of cheap power, physical proximity to major fiber optic backbone networks, and a local government that will actually let you build. Accommodation is rarer than people think. It is why Northern Virginia, specifically Loudoun County, has become the data center capital of the world. More than 70% of the world's internet traffic flows through the corridor on any given day. The land there is not being priced like a farmland or industrial real estate. It is being priced like the most strategically valuable dirt on the planet, because it is. In emerging markets like places like Texas, Arizona, and parts of the Midwest, you can find land that checks all three boxes for a fraction of the cost, but you are still paying a premium that reflects the scarcity of that convergence. Land and site preparation for a 50 megawatt facility, somewhere between 50 and 150 million dollars, depending on location. Let us call it 100 million and move on. The building itself is not a normal building. The floor has to support the weight of dense server racks. We are talking looking lords that would crack a standard commercial concrete slab. The roof has to accommodate massive cooling infrastructure. The walls have to be designed for both physical security and electromagnetic insulation. And the entire electrical system has to be engineered to handle power loads that would service a small city. Industry estimates put construction cost for AI optimized data center shells at around 10 to $15 million per megawatt. For a 50 megawatt facility, that is 500 to $750 million just for the building. Not a single piece of computing hardware has been installed yet. Here is where the AI data center diverges completely from everything that came from it. In a traditional data center, your primary hardware investment is in CPUs, central processing units, the kind of chip in your laptop, just a lot of more of them. Powerful, efficient, relatively affordable at a scale. In an AI data center, you need GPUs, graphic processing units. Specifically, you need Nvidia's H100 chips or the newer Blackwell B200 series. And the reason you need them is deeply technical, but the short version is this. Training an AI model requires performing millions of identical mathematical operations simultaneously. GPUs were designed to do exactly that. It is why they were originally built for rendering video game graphics, where you have to calculate the color of millions of pixels at the same time. The architecture just happens to be perfect for AI. A single Nvidia H100 chips cost between $3,000 and $4,000. A single one, but you do not buy a single one. You buy clusters to train a meaningful large language model, the kind that powers something like ChatGPT 4 or Claude. You need clusters of 1,000 to 50,000 chips working in parallel, connected by specialized ultra-high-speed networking called InfiniBand. Let us run the math on a conservative 2,000 chip cluster. At $35,000 per chip, that is $700 million just in GPUs, and that does not include the custom server racks designed to house them. The liquid cooling manifolds required to keep them from hitting temperatures that would destroy them. The infinite band networking fabric, the power distribution units, or the facility management software. By the time your 50 megawatt facility is what the industry calls day one ready, meaning it is operational and capable of accepting its first client workload. You are looking at a total capital expenditure somewhere between 1.5 and 2.5 billion dollars. Let that sit for a second. 1.5 to $2.5 billion to open the door. For context, that is more than the construction cost of most NFL stadiums. It is more than the capital required to launch a major airline. It is more than the most sovereign wealth funds to deploy in a single infrastructure investment. And unlike stadiums, which will be standing in 80 years, or an airline's fleet, which has a lifespan of 25 years, your most valuable assets, the GPUs, will be technologically obsolete in approximately 3 to 5 years. The clock starts the moment you sign the purchase order. Capital expenditure is the entry fee. Operating expenditure is the lease you pay every single month just to stay in the game. And in this business, operating costs are unlike anything you will encounter in almost any other industry. Every business has a cost of goods. A restaurant buys food. A car dealership buys cars. An AI data center buys electricity. And the electricity bill for one of these facilities is not an line item on a budget. It's the entire budget with everything else as a rounding error. An AI GPU chip is not just computationally powerful, it is the thermally violent. A single high-density AI server rack can draw between 60 and 100 kilowatts of power. Compare that to a standard enterprise data center rack, which draws 5 to 10 kilowatts. We are talking about a 10 times increase in power density per rack. Scale that across a 50 megawatt facility running at a full capacity. You are consuming 50,000 kilowatts, 50 megawatts, every single hour. At an industrial electricity rate of approximately 7 cents per kilowatt hour, and many facilities negotiate below this. With long-term utility contracts, your hourly electricity cost is $3,500 and your daily cost is $84,000. Your monthly cost is approximately $2.5 million just in electricity. But here is the part that most outside analysis miss entirely. For every watt of power you use to run the computers, you need somewhere between zero point 0.3 and zero point 0.5 additional watts just to remove the heat those computers generate. This is measured by a metric called PUE, Power Usage Effectiveness. Perfect PUE of 1.0 would mean every watt of electricity goes directly into computation with zero waste. In reality, even the most efficient hyperscale facilities, Google and Microsoft best-in-class operations, run at a PUE of around 1.1 to 1.2. Industry average is closer to 1.5. At a PUE of 1.5, for every dollar you spend powering the chips, you spend an additional 50 cents on cooling infrastructure. On a $2.5 million monthly power bill, that is another $1.25 million per month in cooling costs. That is why the newest generation of AI data centers is moving aggressively toward liquid cooling, running chilled water or even dielectric fluid directly through the server racks and contact with the chips, because air cooling at these power densities has hit a physical wall. Air simply cannot remove heat fast enough. The chips get too hot, performance degrades, and in worst cases, hardware fails. The transition to liquid cooling is itself a capital investment, but for new facilities being built today, it is no longer optional. It is the baseline. Here is something else that does not show up in the marketing materials. When a grocery store lose power for an hour, they lose some frozen food, inconvenient, manageable, in short. When an AI data center lose power, even for a fraction of a second, the consequences are critically different. Large language model training run can take weeks of continuous operations across tens of thousands of GPUs. If power is interrupted mid-run, you don't just pause and room. You potentially lose the entire run. For a client who has paid millions of dollars for that compute time, that is catastrophic. That is why AI data centers are built to what the industry calls Tier 4 specifications, the highest redundancy classifications. Tier 4 means the facility can sustain full operation through any single point of failure. It means dual power feed from separate utility substations. It means one-side diesel generators capable of powering the entire facility for 48 to 72 hours. It means massive battery-based, uninterruptible power supplies that bridge the gap between a utility outage and the generators coming online. A window measured in milliseconds. The ongoing maintenance, fuel reserves, and staffing required to keep all of the redundancy operational adds another several $100,000 per month to the operating cost. Add it all up: power, cooling, redundancy systems, specialized engineering staff, network connectivity, security, insurance, and maintenance, and you are looking to a total monthly operating expenditure for a 50 megawatt facility somewhere in the range of $5 to $8 million per month, every month, before you have serviced a single dollar of the debt you used to build the thing. Here is the macro point that I think matters the most. We're in the infrastructure phase of the AI revolution, not the application phase, not the consumer phase, the infrastructure phase. Just like the railroads in the 1840s and the electrical grid in the 1890s and the internet backbone in the 1990s, the people who own the physical layer always extract value before anyone else. And they often extract more total value than the application that run on the top of them. The AI data center is not a tech investment. It's a power and real estate investment with a technology component. The moment you understand that, the economics start to make sense. Every time you use an AI tool, every time you generate an image, ask a question, analyze a document, you're consuming a fraction of a second of compute time in one of these buildings. Someone owns that building, someone owns those chips, someone is collecting that fraction of a cent, multiplied by billions of interactions every single day. So the question we always end with on this channel is the same one: would you rather be the person asking the question or the person who owns the building where the answer is made?